Okay, once you know how to identify the number of significant figures in a number, you can then use that to perform calculations. And so we're going to look at some of the rules for calculations, both addition, subtraction, multiplication, and division. However, first, I found that sometimes people need a quick review of how to round correctly. So your notes say, recall when rounding if the number is immediately after the point being rounded at. If it's 5 or greater, round up. If it's less than 5, round down. Okay? In other words, if we have this value and we want to round to 3 significant figures, here's my 3 significant figures, the 5, the 6, and the 1. The next number is a 4, so I would round down, 561. Okay? I don't write 0.0 because then it would have 4 sig figs. In 10,230, here's my 3 significant figures. The next value is a 3, so again, I round down. Some people will do this. That's not rounding down, that's chopping off and giving a number that is drastically different than 10,230. We would round down to 10,200 so that it has 3 significant figures. In this decimal, again, here are 3 significant figures. The next value is an 8, which means I round up. So instead of a 0, I would write 1. So 0.541. 3 significant figures in that answer. If we've got 25,008,000, here are our 3 sig figs. This next number is a 0, so we round down entirely. Again, remember, rounding down is different than just chopping it off. Problem is, and this relates to what we talked about in the first video, I now only have 2 significant figures. This would be an example of where you would be required to record your answer with scientific notation. So I can write 2.50, 3 significant figures there, times 10 to the 7th. That makes it equivalent to 25 million, but shows a precision of 3 significant figures. Okay? With that idea in mind, we can think about how we would get to those values. Okay? I told you in these situations to round to 3 sig figs. Here we're going to put it all together, both identifying how many significant figures there are to start with, and then rounding your answer to the correct number of significant figures. First, let's look at the rule for multiplication and division. The number of significant figures in the answer must equal the number of significant figures in the least accurately known quantity. I found it helpful to just right away state how many significant figures are in each value. So thinking back to our box and dot method, here's a 5, that's our non-zero digit. Because of the decimal, I box the trailing zeros, and we have 4 sig figs. Here's a non-zero decimal, so we box the trailing zeros, and we have 3 sig figs. That means the least accurately known has 3 significant figures, so our answer should have 3 sig figs. From there we can do the math. 5 times 3 is 15. That's pretty straightforward, but we can be a little bit more precise in our answer because we have an accuracy of 3 sig figs. Our units would be centimeters squared. 15.0 centimeters squared. In number 2, we've got 0.1 times 45.2 kilometers. If we look here, we've got 2 significant figures. This quantity has 3. Our answer should be accurate to the least known quantity, so our answer should have 2 sig figs. When we multiply this, we get 4.52 kilometers squared. We can then round 2 sig figs. The next number is a 2, so I'm going to round down. My answer would be 4.5 kilometers squared. In number 3, 6.5 times 2, that's pretty straightforward. That's 13. The math is easy, but our answer can only be accurate to the least accurate quantity that we started with. 6.5 has 2 sig figs. There's only 1 sig fig into the value 2, so our answer needs to have just 1 sig fig. So we would take 13, here's our 1 sig fig, we would round it down, it would round down to 10. Oscillations, or seconds per oscillation times oscillations would give us 10 seconds. as our final answer. In number 4, if you take 10 and divide by 4.5, you get 2.22. There's 3 significant figures in this value. Those zeros are significant because of the decimal, and there's 2 in that quantity, so our answer should have 2. We would round down 2.2 minutes per lap. That is the rule for multiplication and division. For addition and subtraction, the number of significant figures in the answer should match the number of significant figures in the term that has the least accurate place value. That's different. If we look here, we're not concerned with the fact that this only has 1 significant figure and this one has 2. Our concern is this one is measured to the tens place and this one is measured to the hundreds. So the least accurate is this one measured to the hundreds. Our answer will need to be rounded to the hundreds spot. I sometimes find it most helpful to look at it like this when you're first trying to figure these out. If we add them up, we get 570 centimeters, but we can see this quantity is only measured to the hundreds, so we have to round our answer to the hundreds. We'll round here. The next number is a 7, so we round up to 600 centimeters. If we've got 12.4 plus 8.487, again, I'm going to line them up so we can sort of think about what place value each one is measured to. Notice I'm not counting the significant figures in these. I'm looking at place value. We see that 12.4 is measured to the tenths, and 8.487 is measured to the thousandths. Our answer will have to be rounded to the tenths because that's our least accurate value to start with. So when we add these together, you would get 20. Well, let's start from this end. 7, 8, 8, 0, carry the 1. So we get 20.887 pounds. We will round here. Because the next number is an 8, we round up. 20.9 pounds. In number 3, we see we've got 600. That's measured to the nearest hundreds. And 38.5 or $38.50, we could say, is measured to the nearest penny or the nearest hundreds. When we subtract these, you would get 561.50. However, our answer can only be as accurate as the least accurate quantity, which is accurate to the hundreds. So when we round this, the next number is a 6, we would end up rounding up. Our answer is 600. This seems to not make a lot of sense. $600 minus $38.50, and you still have $600. The idea is this. How close to 600 is this? We don't know if it simply says 600 measured to the nearest hundreds. Perhaps you're rounding up your summer earnings and you're saying, well, this summer I made $600. Did you make exactly 600? Did you take $567 perhaps and round to the nearest hundreds? Did you make $628 and just round to the nearest hundreds? We don't know. So our answer can only be as accurate as our least accurate quantity to begin with. It seems not to make a lot of sense. It seems like this would be a lot more accurate, but we have to refer back to the accuracy of what we started with. One final example here. If you've got 62.832 kilograms minus 8.2 kilograms, when you do the math here, you would end up with 54.632. Here we have 3 decimal places. Here there's only 2, so our answer should have just 2 decimal places. We'd say 54.63 kilograms. One final thing that's important, 2 final things. When solving problems, you round to the correct number of significant figures at the very end. It's most helpful to just keep storing those values in your calculator until you've done the final calculation and then round. Okay, and then also just a quick note pertaining to what's called exact numbers. Exact numbers do not affect the amount of significant figures. Exact numbers can be thought of as having an infinite number of significant figures. For example, unit conversions, like 1 meter equals 100 centimeters. That's an exact quantity. You wouldn't say, oh, there's only one sig fig there. You could think of that as having infinitely many significant figures. Other exact numbers would be like 5 people. You would assume that's exactly 5, even though it's not written as 5.0000. You get the idea.